But welcome everyone to our second meetup in New York City. Hashtag OMH NYC. We have tonight's going to be a show and tell, and we have some really great speakers we'll talk about in a bit. So welcome. A few announcements. We are having our first and our debut mHealth Summit in San Francisco on June 17th. If you can't come, please, there's a link right there that you can send to your friends. There is a password at OMH15. If you can, you'll need that to be able to get in. You're more than welcome, and please, there's going to be a lot of great people in the room. It's a small group. It's going to be an intimate group, but it's going to be very exciting, and we're going to learn a lot of stuff. Everyone's going to learn about what mHealth's doing, and we're going to learn about how to make mHealth even better. We're still looking for back-end engineers, so if you know of anyone who would be interested in programming and doing some software development and as a back-end engineer, bit.ly/backend softeng backend, and you can email me at david@openmhealth.org if you know of anyone. Some other announcements: we just launched a new meetup in Chicago. On June 10th, Miraj Choksky is going to be presenting and organizing the group out there. It's going to be at Matter, which is a health tech, I guess it would be like a health tech space incubator. And we have about 72 people. We just launched last week, and we have about 72 people and 55 people going. So we're really excited, and mHealth is starting to spread. We have some also interest from folks in Orlando, Florida, Paris, and we had a very successful event in London as well, and San Francisco. So we're expanding, but we started here, guys. So we're the first. For those of you who don't know about mHealth, I see some familiar faces that have been here before, but our mission is to unlock the potential of digital health data so it can be meaningful in the clinical environment. We build open source code that helps developers save time in using digital health data. These are some sneak peeks of our new website, so you guys could take a look. But for those of you who don't know what's possible with mHealth, you can standardize data. We spend a lot of time working with clinical experts and with tool makers to try to understand how to best to represent data. What are the clinical standards that we should be referencing? How do we basically create a sort of a common language and a standard for digital health data, so it doesn't really matter where the data comes from. There's a common way to represent this information. mHealth provides a way to store data. So again, it shouldn't really matter where the data comes from, and that if you wanted to store data, there's a way to do it. We don't host data, but there is a mechanism to store it. We also have a server solution that will allow you to integrate data from disparate sources like Fitbit, Jawbone, Renkeeper. We're about to push out a new adapter to Google Fit, and we're going to be talking about some others tonight. If you have an app or device and you want to build an API, we have a way to do that as well through that storage component, which has this feature as well, so that if you wanted to share that data with others, you could process data that's been come out in the mHealth way, and you could also visualize it. So that's just a little bit of some of the stuff that we offer, and if you go to github.openmhealth.org, you could take a look at some of those offerings and get deeper into the code if you need to. Tonight is really special. It's really exciting. We have 3 speakers. We have Brent Hargrave, we have Andy Hsieh, and we have Nosh Petigara. Yeah. They're going to be presenting about their uses of mHealth and doing stuff with mHealth data. So let's just take it away.
All right, so my name is Brent Hargrave. I'm a freelance iOS developer. I do some backend too. And I've known David for a couple years now. And so for the past month, I've been helping them with their mHealth support for the iOS platform. I don't know what this is. So I guess I'll just dive right in. What I'm working on, I guess the genesis of, that's the prompt for this, of a lot of the projects that I'm discussing today are kind of date back to a conversation we had months ago about building an app that would, what we were doing is talking actually about how Dropbox's native iPhone app does a really great job of backing up your photos in such a way that you're actually more confident in Dropbox's solution than you are in Apple's own solution for keeping track of that really valuable data. And out of that conversation came the idea of, along with how valuable all this health data that's being collected on the phones is, it would also be useful to back that up as well. So that spawned the idea for an iPhone app that would do something very similar to what the Dropbox app does, which is as your iPhone collects data on on how many flights you've climbed, how many steps you've taken, your heart rate, et cetera, it collects all that data and will back it up to Dropbox in the same way. What I want to talk about is what happened. OK, so we talked about building that iPhone app. And as a precursor to building that, we discovered that what we would need to do is build a specific iPhone or an iOS library that didn't exist already that would be necessary to build this app. And that library is called Granola. And the reason we called it Granola is because it is a helpful serialization library for your data.
Could you explain what serialization is?
Yeah, I'm going to get to that. OK, so I figure if you're not laughing, it's like for one of two reasons. One, you don't think puns are funny, and you're wrong. They're hilarious. But if you're one of the others, then you may just not understand exactly what the pun is. So I'm going to explain what serialization is, and through it, highlight how this is actually a really great opportunity for this particular library. Yeah, Granola is a serialization library for your health app's data. So the best explanation I can come up with, if I was to try to explain to a layman or provide a layman's explanation for what serialization is the distinction between having an idea in your head versus writing the idea down on paper. This is how I explain it to a relative who didn't understand like computing and stuff like that. So the key, why this is a useful metaphor is that in the same way that you have an idea in your head, but nobody else can understand it until you write it down or speak it, there's a parallel to the computing world where there's data in memory. They actually use the metaphor of memory here as well, where it's accessible within that particular process on that machine, but it's not until you serialize it, that is, write it down, that another device can see the same data. So what serialization is the process of transforming the data into a format that can be shared with others. Unfortunately, Apple actually passed. They did provide, I mean, who here has an iPhone? OK, it's like maybe 75%. How many of you have actually opened the health app on your phone? How many of you check it like weekly? All right, we have one. Wonderful. It's not the most popular app, but it is really good insight into the health data that is being collected by your device. And below that, below the Apple Health app, there's an SDK, or a software layer that any developer can get access to called HealthKit. And HealthKit is wonderful if you're building an app for someone's device, because you can actually talk to HealthKit to find out all of the data that's been collected by the device. So an example here would be Runkeeper. Runkeeper has an iPhone app, and they can actually read HealthKit data to find out that, for example, I ran at 8 a.m. this morning. The problem with this is that if Runkeeper wanted to take that data and put it someplace else that Runkeeper cares about, off of your device, like, say, runkeeper.com, or if they wanted to back it up for some reason, they actually couldn't do this easily. And the reason for this is because they can access the data in memory, but they can't get it to their server. There's no serialization. Apple hasn't provided a serialization library. And they probably have good reasons for doing this. A really great blog post by a prolific iOS developer. Actually, I guess he was at a WWDC conference, which is their annual developer conference, and found out from one of the developers that the reason they haven't supported, well, he was specifically referring to JSON, but this is probably the same reason they haven't done serialization for HealthKit specifically, is that when they do so, they're committing to maintaining that sort of solution for like 10 years. I mean, it's a big endeavor. So they're conservative in what they roll out, and that's understandable. What that does is it leaves an enormous gap for everybody else in the community that wants to use that data. And that's the gap that Granola fills. So there are a couple points I wanted to make about why this is actually such a big opportunity as an open source library. Primarily because for any developer, this is the sort of thing you don't want to have to do yourself. It's the code you don't want to have to write. And that's for a couple reasons. One, serialization code is extremely boring to write. If you've ever had to do it, it's basically just looking at documentation on one type of data and figuring out how you're going to write it out to a string. It's very tedious, and it's not necessarily related to the business problem you're trying to solve. It's just like low-level plumbing that just has to be taken care of, which is why he wrote that this is something you would expect HealthKit to provide. And the fact that there isn't means that every developer who wants to write an application that uses this data has to write their own serialization. So they have to go through the same process. And that process is actually, in this case, particularly onerous because with health data, there's a lot of it, and it's very diverse. So there's a lot of different kinds of things that you would have to take into consideration if you wanted to write a serialization library. So this is a screenshot of our, you can't even read it actually, but these are the different data types, the different types of health data that you can actually read out of HealthKit, and that if I, as a developer, had to be able to use to send to a server, I would have to write mappings for each of these. Apple's done a good job of providing some generalizations. It actually falls into like 4 major categories, but there are nuances to all this data that I certainly don't feel qualified enough to answer. So it would be really great if somebody could answer how to do that serialization for me. This is what Granola does. And obviously this is great because once it gets solved, this is true of any open source library, when it gets solved once, it gets solved for everybody. So I think this is especially important, not just for the open source community generally, but if you think about anybody who wanted to write a health application that read, say, your steps data and did something with it, they would have to write this. And it's especially true of any application that has like real reach. Like if you think of your favorite services, almost all of them don't exist just on the phone. There's, perhaps my favorite health app is one that tracks my sleep, and even it has a backup feature. It's very small. It doesn't have a lot of interface to it, but you know that they have to get that data off the phone to be able to provide that service. So they have to solve the serialization problem as well. So Granola solves just, I think, a tremendous problem for a lot of the people in the space. And as an offshoot, everybody who uses this library, they're not just solving their specific developer problem, but by using the formats that mHealth has developed, they're using data schemas that are actually clinically meaningful. And so they're actually going to help people at some point. And it certainly, at least the way I've seen it, makes the data a little more intelligible as well. Like understand what it's for. So you get to do the right thing as part of solving your own problem. One point I'd like to make about Granola is that we've actually extracted it from a real production app. Oftentimes, if you find that somebody has written an open source library sort of in a vacuum, detached from any sort of like real user application, it can solve the wrong problem, or it just won't really work for many other people. We've gone ahead and actually extracted this from a real app that does something that people ostensibly might be interested in, which is backing up their HealthKit data. So it works and is probably generalizable to the sense that other developers could use it too. It's a decent segue to the purpose of the Granola, which was to help make Hipbone. And I'll go ahead and demo that now. Basically, you just download the app. It's a very simple user experience, actually. There's not a whole lot to show. Most of it happens behind the scenes. But we give you the initial pitch, which is just an explanation of the value, which is that it'll back up all the data that's being collected on the phone passively behind the scenes. And we're using, right now we're using Dropbox as the store, but in theory we could use this, we could apply this to any backend store that you might like, Google Drive. If you have a home rolled server, we could do that as well. So I'm just authorizing Dropbox, which lets the application write to my personal Dropbox. And And then we ask you for access to your health app data. For most consumers, the visibility of this is just that health application, but I think we all know here that we're actually asking for a lower level access layer. But anyway, it prompts you for access to the different data types. Right now, because Hipbone is built on Granola, it supports the most popular types of data that we care about, like steps and sleep analysis, things that people are likely to use. But in theory, this could include all of the types that I showed you in that one screenie. We're not there yet. We'll soon, I think, have support for that, probably within a month. Yeah. So what it's doing is it's reading out some of the most recent data. And then passively in the background is going to begin writing it to Dropbox. So really, this is a lot of the same data you would see in your health app. It mirrors it really one-to-one. So we can see that I recently took some steps. I don't know what time it is now.
If you look at Dropbox up there, you can see it loading in the toolbar.
Oh, yeah, right. Right, so just the step count, when it actually was recorded by HealthKit and when we actually wrote it to Dropbox. And then the OMH formatted JSON. If you're curious to make sure that it's actually backing up, you can go within the app and open up Dropbox and choose any of the files. And if it opens. Yeah, so you'll see basically the same thing that you saw in the app, which is just the OMH formatted data. And that's more or less it. Basically, you can just put this in your pocket and walk around, and as your heart beats and as you take steps, all the data that shows up in HealthKit will also show up in your Dropbox. So that's pretty much it. What's that? Yeah, right? Yeah. So does anybody have any?
So when it stores it in Dropbox, so it's, I'm assuming, text files of the OMS representations, and those are segmented by day, how is that?
At the moment, there's no segmentation.
So it's one big file for each?
Well, it's not one big file. What I'm actually doing is taking each data point. So your steps data is collected on maybe 5 steps at a time, but it's relatively small data. So basically any time, and this might be every 5 minutes, the data comes in, I just write one file. And I'm actually just using a UUID provided by HealthKit as the file name, just because it's simple. It also lets us use Dropbox as it's an identifier, so we can easily fetch the data back out.
Some questions over here, I saw.
So how do you so suppose I've already backed up the data, right? So now I go to the next day, right? Now, do you do an incremental sync for the next data, or you just create new files?
It's an ongoing process, actually. So the neat thing about HealthKit, the low-level API below the health app, is that we can say, I'm interested in all of your heartbeat data, or all of your steps data, and I want to know anytime you create new data. And you can actually just close both apps, and as you create the new data, without having to open the phone, HealthKit will tell our app that there's new steps data, and it'll actually just write it to Dropbox behind the scenes. So in theory, you never have to open the app again, and it'll just keep providing that syncing process. Does that answer your question? Okay.
And if you wanted to say your name and your affiliation, if you have one as well.
Yeah. My name is Dawood. I'm the CEO of 2 Cents. Are there APIs for doing a restore as well, or is this just a one-directional thing?
This is just unidirectional.
Okay.
It would get a little more complicated if we were going to provide the restore that you're describing.
But I'm assuming Granola does serialization in both directions, right?
Right now, it only does serialization.
Okay.
If you want to do deserialization, we were going to have to design our own in-memory objects. So we have to decide if there's really demand for that. If you decide that you'd like that,
I demand it right now.
great. We'll build it. Like I said, it's about extraction.
Open source, so we can.
Yeah. All right, I'll build it. And the other thing I was asking is, because I want to use Granola to create a crowdsourced big data application where I have many different users that are pumping using Granola that are pumping their health data into some crowdsourced system where then they get some benefit from having all of their data together with everyone else. Is there in Granola, is there a method for handling identification of the user?
No.
Right.
This is a very
each item with an ID, or is it self-identifiable? Like any kind of metadata. If you give me a text field, I could use that.
Yeah. So the way I would go about solving your problem is HealthKit itself, the data objects have their own metadata like dictionary basically, and they created that specifically for these sort of open-ended data needs. We could do something similar to that, but we don't have any sort of like internal user notion. Really, we were just trying to make sure that we could capture just the data that HealthKit is providing, and I think the metadata dictionary probably provides the flexibility you need for other needs.
Yeah. So more along actually what he's asking about.
Who are you?
Oh, I'm Kevin. I run an Android consulting company actually, so opposite side of the world sort of. But yeah, like is there any plans to take something like Hipbone and open source it that he can write an app that would deliver the data after registration to a server that he's talking about as opposed to Dropbox?
We could certainly. I think we've talked about doing that. We don't. That's not part of. I mean, Granola is really just about the serialization.
Oh no, I'm just saying like sort of turnkey. Like I'll just
Yeah,
this
totally.
project. You could write an app, turn it on, person registers, then it's whatever. You know?
Yeah.
So
It's-
actually, Andy's lab, at Small Data Lab, built an iOS client that will push data to an OpenMHealth data store. And it will conform, the data will be stored as json anyway there. So conceivably, if you matched Granola and this iOS client, then it's not a full app though. It would be.
Oh no,
yeah.
I think that's kind of like, then he just takes that and says import
Yeah.
wraps and stuff, log in, and I'm done.
Yeah.
Right.
There you go.
Well, so we can post that library, that other library as well, the client library.
I think this would be really cool if it went the other way as well. Because right now, I don't know how it works. I guess if you don't back up your phone and you lose it, then really all that data is gone, right? But if you had this that was serializing and deserializing, then you could restore all of your health data out of your Dropbox account.
This is true. I think our inspiration here was, have you used Carousel, the Dropbox app? They don't do restore. It is something you could do in theory. There are like some wrinkles there around like making sure that unique identifiers are the same in the store. I don't know that you can actually set them. So it's a more complicated process of trying to like do that restore.
Does iOS even have the APIs for that? Do they even offer you to?
Yeah, there's a write API.
Okay.
You can write.
Okay.
Yeah.
We need to keep it.
Sorry.
Any last
Yeah.
questions? No, this is great. Any last questions for Brent?
I have one quick question, right? If you want to store this in a database, right? It would be relevant. What kind of database would you use? Because we've been trying to do this in iOS and PHP, and what we find is the HealthKit data, right, has different structures. Like there are many different kinds.
So you're asking if you're going to build a backend service,
Yeah, where this can be stored.
what database would you use?
Yeah, it can be stored in a database, right, for queries and all. Right?
Oh, sure. It's really, I mean,
The DS Studio, which is
JSON that goes straight into MongoDB.
yeah. And so we have an appliance that you can data storage that will store all the JSON data, and then it will put it into MongoDB. Yeah.
you could use other data stores too. Anything can store
Yeah.
strings.
Well, we'll keep the conversation going after with some more drinks and stuff. But Andy, why don't you come on up? Andy is a PhD student at Cornell Tech, and at the Small Data Lab. All right, let's give it up for Andy.
Thank you, everyone. My name is Andy Hsieh. So I'm a computer science PhD student, actually from UCLA, although I'm doing research in Cornell Tech right now. So today I would like to talk about something we call Homage ONH. It's like a software suite for mobile health study. We help like different physicians from people from the hospital for special surgery and people from the NYC NYC Genomics Center to deploy the study of different sites and to collect the data from their patient and to do analysis and to help them to make this data, mobile health data, actionable. So that's what we do in the small data lab. And and all this like system is built on top of open mobile health platform. So I'm also going to talk about like how we use this platform and how this platform make our life much easier after we migrate our system to this platform. So let's get started. Yeah, so this is some background about me. Computer science PhD student, and my advisor is like David Estrin. And at the same time, I'm also a full-stack developer. Like I do like developing on the mobile application, web application, and the backend application. And I mean, I write a lot of code every day. And I have been involved in the this like Homage ONH project like for about 1 year. So what is Homage ONH? Especially mean homage on open mobile health platform, and you can find more information about this platform. Everything is open source, free to use. We are more than happy to help you to run your application, run your own instance of Homage ONH on your own server. So as I say, it's an open source mobile health software suite and built on top of open and health architecture. And we mainly offer 3 mobile apps, both on Android and iOS, so it can accessible for most of users. And this app collect different mobile health data, which I will give a very quick demo later. And we also have a research dashboard that allow researchers to deploy study of different sites. Like we have study of more than 50 users, and it's going to have like 150 users. And we also run study with small pilot, like only 5 or 3 users, and just like get started and going forward to a larger like deployment. And these are our current users. So we have collaborators from hospital for spatial surgery. They do some like monitoring their patient after they do their knee surgery or hip surgery and see their recovery. And we also have a collaborator from New York Genomics Center to look into their RA patient and see how RA happen and when they're like onset of RA. And we also have collaborators from the Cornell Medical School that they do like all the different kinds of study with us. So yeah, so what I'm going to do today is that I'm going to show a quick demo of the 3 mobile apps that built on top of mobile and health platform, and also a research dashboard we developed for the researcher to deploy studies. And so the first app I would like to demo is Homage Mobile. So it's the main app of this whole platform. So this is a mobile self-report app. You can think of this as like SurveyMonkey, but it's a mobile version of SurveyMonkey, but it's more powerful. It supports like the time-based reminder and location-based reminder that can remind me when I enter some specific location. And it supports like different kinds of survey, like text survey and multimedia survey. Just a quick demo here. Homage. Okay. Yeah, so it's very easy to use, and I would kind of optimize the user experience. So a lot of participants, they find this application easy to use. So just enter Homage, and once the participant enter Homage, you will see the survey that's available to this user. So we like kind of segregate the user so that they will only see the surveys that belong to the study they join. So they won't see other people's study. And I'm kind of a test user, so I can see most of survey here. And let's just take a quick survey about RA. And so like about like, just very quick. So we have a very nice like number wheel and a single choice question, multiple choice questions, And yeah, should not at all. Single choice question again, another single choice question. Let me go through it very quickly. Yeah, so like once participant answer all these questions, just hit submit. So the data just go to the server immediately in a very like power efficient way. So it won't drain their battery. And we also support like multimedia survey. So for example, you can take a picture, just take a picture of my, my laptop right now. Yeah, submit the photo and skip this one and hit submit. So the data, once I hit submit, the data like saved locally, and it will be uploaded to an open mHealth backend. Like at the time we find kind of most power efficient time to upload the data. So this is the first app. It's Homage. It's a survey taking app. The second app, I think I can just directly go to the demo. The second app that we are building is called Mobility, right over here. So Mobility is an activity tracking app. It's kind of similar to those like commercial alternative like Moves or the Pacer. And the main difference is that our app is open source, and the user will own the data. Like you don't need to worry like suddenly one company they shut down the shop, so you lose all your data, or suddenly the company just get acquired by Facebook and yeah. So actually initially we kind of recommend people to use Moves because it got a much better user interface and the user like it. But people start to have concern once Move get acquired by Facebook because they just don't want their data be on Facebook, seen by Facebook. So like we developed this app, and it's both available on Android and iOS, and user own the data. You can host your own server, so only you can see your data, or you can use our service and you can take away your data anytime. And our algorithm is all open source, so you can develop on our algorithm to extract information you want. Like I can show, just to give you a better sense of what kinds of data you can learn from these kinds of continuously activity tracking. I can show you a visualization here. So this is my mobility data, and this kind of pretty real time. This is my today's data. And you can see like I walk around in like the Chinatown, and this is kind of all my location samples. And kind of something interesting is that based on this location and activity data, we extract some data, some like more meaningful information over here, like how much I walk, the distance I walk in a day, and the walking time in a day, and what is my like max gait speed, which people find kind of have some like correlation to some physical condition, like, and also my geo diameter in a day, which is a good like signal to like how active I am during the day. So one kind of interesting research question, kind of I'm particularly interested in this mobility data is the gait speed. So there's a lot of research talking about use the gait speed to infer patient their physical condition. But how they measure the gait speed, if you go read their paper, that's that they have in a very controlled environment, and there's a ruler on the ground and ask user to, hey, so walk in your normal speed, which is kind of pretty hard for a lot of people in that environment just to contrive. But with this mobility data, we can have a very good like sample of like how people walk in their daily life and how people behave in their daily behavior, and it's more natural way to measure this information, and we probably can get like better quality of the data. Okay, so this is mobility, and everything here is open source and available on Android and iOS. And the last app I want to demo is called Pen. So PEN, the full name of PEN is called photographic effect meter. So it's basically a simple idea that we want to measure people's mood in a more enjoyable and easy way. Like traditionally, if you want to measure people's mood, you ask them to enter a very, very long survey. But here we just ask them to do one thing. It's that, can you choose a picture that can best describe your mood at the moment? And like right now, I would say I'm super happy to be here. So let me choose this one. It really represent my mood right now, and I just hit submit. Yeah, so the data right now is uploaded to the server. And this app also comes with the time-based reminder. So it will remind you to take this survey like at the time the doctor wants you to take the survey. Okay, so this is pretty much the demo of the app. And so these all 3 apps. Okay, so last thing I want to show you, again, built on top of Open mHealth platform, is a research dashboard. So only this app is actually not enough for the doctor. So they need a way to deploy study, to manage a study, and they need a way to kind of extract kind of meaningful information from this study. So we built a research dashboard that gives them a very easy way to monitor their patient, their compliance to the study protocol. So I can just show you a quick demo here, and all these are internal users, so it is fine to look at their data. So these are, I log in as the researchers, and I can see the data of the patient who belong to my study. I won't be able to see other patients' data. And all here are internal user, and we can monitor that, see, hey, if the pen data is coming in, mobility data is coming in or not. And let me just choose one user's data. Like I can see this user's data. Tables data. Yeah, so here we show a visualization of these patients' mobility data, and like which are the 3 variables we find like most useful to the physician. The first one is the walking speed, and the second one is active time in minutes, and the time not at home, like how much time you are not in your home, which kind of can indicator to your like active level. And we represent, like overlay this data on a calendar view, which we find kind of the doctor, they more tend to read data on this kind of calendar view so that they can better communicate with the patient, say, hey, so what is going on in this particular day, and so what is the like condition in this particular day. And so this is the calendar view, and the patient can also, the researchers or doctor, they can also export the data very easily, just click and they'll download all the mobility data for this patient. Okay, so I think that's it for the demo today. And so the next thing I want to talk about is our story of using the open mobile health platform. So Homage, actually, this whole system started as a kind of standalone system back in like 2009. And so it has its own interface, speak its own language, which is fine in 2009. But over the time, you will see that there's a lot of new services coming in. Like you have like Fitbit and Moves and a lot of new apps, new services coming in. And a lot of time when these like doctor or researchers, they are looking for maybe they are looking for a subset of data we are able to collect. But a lot of time they are looking for the data that is only able to collect by one of these apps. So we did build some ad hoc solution for them to get the data from some of these services, but none of these solutions we really like them. It's just like you have a lot of code scattered around in your house and you just don't know how to organize them. So like since like 6 months ago, we start to migrate our system to the Open Mobile Health platform, and we use the backend to store the data, and we also use the machines to connect it to all these different kinds of services. So the result has been very, very good. Like when we need the data from these services, we just run our Shin server, and if any like researcher they want any of this data, we just say, hey, it's over here. You just use this URL, and you can start to collect this data. And the data will available on the dashboard, which I show you immediately once users sign up. And another thing we find kind of very exciting is that once we migrate our system to this like larger ecosystem, our app or our system have more opportunity to be used by other people. Like if one startup, they are also using some smart keyboard to measure some fine motor thing, and they also want to use Homage to have some self-report of their participant, and they can very easily to get data from us because they also speak this open health platform. So that the result I would say has been very great, and thank you, David, and the developer in Open Mobile Health that give a lot of support to us. Yeah, so that is my talk, and just the development team of Homage ONH. Charlie is an iOS developer who only will be available in like Cambodia or Thailand, but he's talented, super talented. And Jerry is like backend and Android developer, super professional. And Judy is our dashboard developer. She built up this dashboard in very short time and have amazing results. So we have a great team, and so everything I talk about here is open source, open to use, open to modify, and we are more than happy to help you to run your study or host your own server. And that's it. So you can contact us through this website or through this email. Thank you.
Does everyone have any questions for Andy?
Is there any charting feature in the framework, like charting for graphs and all?
Right now, we the charting feature is more kind of ad hoc charting feature right now. We don't have, say, a very extensive charting library, but we do have some visualization, like what I showed, the mobility visualization and the calendar view, which we find useful to the doctors. But we don't really have a very kind of extensive charting library to do all the different kinds of charts right now.
And all that data is coming through the Android phone, like the duration and everything?
Oh, you mean how often, or?
Yeah, like how do you get the data from the Android phone? Is there equivalent of like a HealthKit or something on Android? Or?
Yeah, so the data we collect is that we have a library that will talk with the Open and Health, their backend. And this library is more like an data uploader library. And this app will write the data to this library. And this library will find the time that is most power efficient time to upload the data. So, and this library is open source. So if you want to use, you can find it on our code repository. Does that answer your question?
Yeah, no, I was just wondering, so the library, the user has to install the library on the phone?
The user only need to install the app. So each of these apps come with the same library that will upload the data.
So in the same way that a Hipbone app might have will push the data to Dropbox,
right?
There's already a library inside of the PAM and Homage app and whatnot that will push it to Represent Health Data Store.
Hipbone is getting from HealthKit, right? Where are you getting from the Android phone? Where are you getting the data?
Oh, the data is collected by our app. So so the data we collect, this data use the app, the self-report app, mobility app, and those apps will collect the data.
From the phone?
Yeah, from the phone, yeah.
Sensors on the phone?
From the sensors?
Yeah, it's all from the sensor on the phone.
Yeah.
Android, yeah.
Well, let's keep it going. Thank you, Andy. And if you have more questions for Andy, please give him
talk to him afterwards. I think it's a really big deal that the small data lab and Andy and the rest of the engineers built something that could be very useful for clinical research. A clinical researcher could get off the ground running and have a way to be able to put the data somewhere and it's can run a study. Our next presenter is Nosh, and Nosh is new to the OpenMHealth community. I think you guys will really like this. Take it away.
So hi everyone, I'm Nosh. I'm going to talk today about developing with OpenMHealth APIs and OpenMHealth data formats, and give you a demo of Octi, which is a little plugin that I built for Google Spreadsheets that allows you to, with a few clicks of a button, pull data from any OpenMHealth compliant data source. So pretty much any sensor from a set of about this 20 or so that OpenMHealth supports today, and a whole range of different clinical measures. And as David mentioned, I'm pretty new to the OpenMHealth community. I only sort of found out about OpenMHealth a couple of months ago, and that's when I reached out to David. And I actually started looking at the software about a week ago. So everything that you see here is pretty much hot off the presses. And I think it's really a testament to the potential of the OpenMHealth software and ecosystem to really enable developers to easily and effectively pull this data into their applications. So although I'm new to OpenMHealth, I've spent the last year or so consulting for a pharmaceutical company and designed and built them an application that allowed them to wire up a whole set of their patients with wearable sensors to really understand whether their patients were adhering to their medication regimen, and also to give them sort of broad overview and insight into their activity patterns and sleep patterns, with the end goal being that they thought that using this system and sort of intervening at the right times, they could improve the clinical outcomes for these patients who are on essentially long-term drug regimens. So that's going through clinical trials at the moment. Historically, for historic reasons, this system didn't use OpenMHealth at all when it started out. I think you guys were probably just getting off the ground. But when I came across OpenMHealth, I sort of set a light bulb off in my head, and I was sort of thinking this would actually have been really great if we could have used a lot of this infrastructure to build this out, because and so what I was really interested to understand was that by using OpenMHealth, can you really reduce the time and the cost to develop a system like this? That's when I reached out to David. And sort of another bonus for me is a lot of the OpenMHealth infrastructure uses MongoDB as their database for their reference implementation. And that was my previous company, so I wanted to sort of see how it was used there. And so I was looking to answer two questions really, and the first was, does OpenMHealth really deliver on its promise? And I didn't know it looked great in theory. I saw what the schemas looked like. I saw a whole repository of code up on GitHub, but I didn't really know the answer to that. And then the second thing was that, can I build something fun with it? And that's sort of where the idea for Octi came up from. And Octi is a plugin for Google Sheets. It allows you to pull data from any wearable sensor or any wearable device that you may be using. So whether that's a Jawbone or a Fitbit or a Withings digital scale or blood pressure monitor. And with a few clicks of the button, pull that data into Google Spreadsheets. So then you can just explore the data, see what the sensors are collecting, or visualize it, or do some basic analysis on that data. So what I'm going to do today is spend about 2 minutes talking about how it's built, which I think might be more interesting to the developers, and then just show you the demo, which hopefully will be interesting to everyone. So this is what the Octi architecture looks like. At the core is a piece of software called the OpenMHealth Shim server. And what the OpenMHealth Shim server is this data translator which is able to translate between proprietary data formats that the whole variety of different wearable vendors use today, and each of them has their own specific format, and then translate that into the Open mHealth compliant format, so that an application like Google Spreadsheets can actually use this data in a standardized way across a whole different range of clinical measures that may come from a whole different range of devices. So what I did to build the system was take the Open mHealth shim server, and pretty much didn't have to really do much modifications. I set that up on Amazon Web Services, which is the Amazon cloud. So there's a server living out there which can do this data translation. And then I built a plugin for Google Apps, and specifically for the Google Apps spreadsheet. So most of you are probably familiar with Google Spreadsheet. It's part of Google Docs. They added a feature, I think, a couple of years ago where developers could build plugins or add-ons for it, which then, if you want, you can do it for yourself, or you can package it up, and they actually have an app store to do it. And what those plugins allow you to do is essentially build mini applications inside of Google Docs or Google Spreadsheets. So in this case, the Octi has a little UI which allows you to pick which devices you want to suck your data out of, what range and for what measures, and then it does that automatically by going out there with its many tentacles that are provided by Open mHealth to get your data. So any questions so far? Okay. So why don't we dive into actually doing a demo. And what I'll load up here is my Google spreadsheet. And I hope someone can you guys read that reasonably? And so when you build an add-on, or you add an add-on to your Google's apps, you get this add-ons menu. And I have one here that I called mHealth, which is the one that I built. And then you ask it to Octi to go off and fetch, right? So you click that, and then Octi pops up this little menu for you. And what you can then do is choose a clinical measure that you would like to look at. So the first one we're going to look at is, we're going to get really personal here. It's my blood pressure. Not my weight, but my blood pressure. And I'm going to use, and so then I choose which device this is going to come from. And I have a Withings digital blood pressure monitor. So we're going to choose the Withings here. And then I'm going to choose a date range. So let's say from let's say from April 1st to May 15th, I want to pull all my blood pressure readings. I'm just going to hit get data here. And it's pulled all my blood pressure readings, which I've actually not been too diligent about taking them, so there's not that many there. And so we'll go and play around with that a bit, but I did want to mention one more thing. You see that user field up there, that's for Nosh. So I can't go off and pull just anyone's medical data. What the Open mHealth shim server has is the capability for you to go in and authorize it to suck up your data from a specific device vendor, and it has that whole sort of authorization flow built in. Eventually, hopefully that will be part of this app, so you can authorize yourself right in the app, but that had to be done sort of in a separate process, and so I'm authorized, and it's sucking up my data. So what we have here is a bunch of blood pressure readings, and if you're familiar with the Open mHealth schemas, you'll see that this maps almost one-to-one. And what I've done is taken the Open mHealth data, which comes in a JSON representation, and translated that into a tabular form so it can be put in a spreadsheet. And so you have the time frame element, which says when the reading was taken. You have your, obviously, your diastolic and systolic pressure, and then the units that those were captured in. And I didn't really have to do any work to do this, because Open mHealth just does this and makes this data available in this totally logical, reasonable format, which if you've actually looked at any of the formats, the proprietary formats that the device vendors provide, this makes so much more sense, right? And the great thing is that when I do it once, I now have support for blood pressure readings from any number of the vendors that Open mHealth supports, right? And so now this data is sort of live and part of Google Spreadsheets. So, nothing magical here, but what we'll do is let's start charting this out. So let's look at my diastolic, and let's look at my systolic here.
It's actually systolic and diastolic.
Did I mix those up?
Yeah.
I guess I did. See, that's why you should not extract any clinical relevance from this presentation whatsoever. So here I can chart it, and just modify the graph a little bit here. Great, and let's see. Great, and I'm sort of missing the part where it actually labels these, but since they're incorrect anyway, I'll leave that off. So which one is the higher one? You said it's systolic. Okay. So sort of at a glance here, you can see sort of my systolic, ranges between, roughly, a little under 120, going up to close to 100, 130x, and my diastolic is sort of around between 80 and 90. So relatively okay, I guess. And this is fully interactive, so because these are all just standard features here of Google Spreadsheets. And of course, you can start building, depending on what you want to do with this data, you can actually start manipulating it, calculating things based off of it. So let's say I wanted to build a little application that tells me how often my systolic went above, or what percentage of time my systolic was over 130, right? That's really easy to do in this spreadsheet. So, I can just make a new column here. I can do a formula here if my systolic there is greater than 130, then record that as a 1, and otherwise record that as a 0. Oops, I think extra per. Yep. Right. Oh. It's B2. Right, and then I can just drag that down for all of my readings. And this is basically just giving me a 1 or 0, whether it's high or not. And then I can take a look and see, I can just average these all out here, and what you can see is a third of the time my blood pressure was, or a third of the times that I took the reading, my blood pressure, my systolic was over 130. So, and obviously this is pretty trivial, but you could get pretty sophisticated with what sort of calculations you're doing. You could group them. They're actually, if you looked at some of the data, some of the readings are very close together because I took multiple in a day. So you could, sort of build a model of, does a patient's blood pressure go over a certain time, how many times in a month, with what periodicity and things like that. So that's sort of a very quick demo. I was going to do another demo using my step data, but any questions or thoughts so far?
So are those like time frame data compatible with the spreadsheet? Can spreadsheet understand those
Yes.
time frame data?
Yeah. So we'll actually see that in the next demo that I was going to show you. So the open mHealth data representation isn't 100% compatible. Like Google Spreadsheets, and I doubt Excel either, recognizes that as a date. But there's a very simple conversion that you can do that will tell Google that it's tell a spreadsheet that that's actually a date. So I'll start a new sheet here, and what I'll decide to do is I'll decide to pull my physical activity or my step rate data, and I'm going to do that from the Jawbone. And this is basically, I'm not wearing a Jawbone sensor, but I have the Jawbone app on my phone, and that's recording the data as I walk around. And what I'm going to do is pull sort of up-to-date data from Jawbone. And so you can see there's a whole bunch of readings that are coming off of this. And these are sort of raw readings from the Jawbone app. So it's taken multiple times a day at some interval that I don't really have control over. And it records the number of steps that I've taken in some duration of time based on the algorithm it uses for recording the steps. But let's say I wanted to do something like figure out, like, when am I lazy, right? What is my laziest day, right? Now that this data is in here in Google Spreadsheet, that's really easy to do. So the first thing that I need to do here is basically take that time data, and because that time is both a date and an actual time, and convert that just into a day. So I'm going to do that here with a couple of different formulas and some formatting. So I'm just going to drag this down here for all the readings. And then format this as a date, right? And so that's formatted as a date. So you'll see there's probably about 15 readings from the first, 15 readings from the second, and so on. And then I want to figure out what day of the week this is. So I can do that with another formula. I think it's called weekday. And that returns me a number. Sunday is 1, Monday is 2, and so on. And now I have all the data that I need to do my analysis, so I can just pivot this data. Right, I can add a field here. And now these are all the unique dates, so it's about, I think, a little over 2 weeks of data. And then take a look at the sum of my step counts. So this is summarized how many steps per day I've taken. But this is for individual days. Still doesn't tell me what day of the week those are. So I can just add a column there for the day of the week. And now you see a pattern of basically how many steps I've taken on specific days, broken down both by the date, the actual date, and by the weekday. And the weekday is here up on the top, with 1, 2 corresponding to Sunday, Monday, etc. So what I can then do is I can average this out for each day, and pull that across here. And now I have my averages for each day of the week. And let's just get the actual names in here. Oops, this is should be Sunday. Yep. And it's pretty smart. It actually did that automatically. And then what we'll do is we'll just get this into, just transpose it so it's in a better format for graphing out. Right, so now we have each day of the week and the average number of steps. And again, we can just chart that out and we'll get the answer. Right, and so the short answer is I'm laziest on Sunday, which I don't think should come as a big surprise to most people. It was actually interesting just looking at this data. Some of it made sense to me and some of it didn't, and admittedly it's only for the last few weeks. But I usually I try and run on Monday, Wednesdays, and Fridays, and you can see Mondays and Fridays have a lot more steps than the rest of the days, which makes total sense. And Wednesday is the next highest, but I've obviously skipped some runs on Wednesdays, and I'm definitely laziest on Sunday. So sort of the possibilities with something like this, are just basically your imagination. And with this little exercise, I was sort of able to answer those two questions. And so, does OpenMHealth deliver? I think it definitely does. It's made building an application like this so much easier than it would have been just a short time ago. And obviously, can I build something fun with this? I mean, if you're like me and you think playing around with your health data is fun, then you definitely can. So, if anyone thinks this is interesting, or, wants to work on this or wants to use this, please let me know. This is really just, a prototype. There's a lot of different things to figure out. First of all, like, is this even useful? And then, a lot of the actual work to make sure that it works for, really works for all the devices appropriately, and, making sure that it's secure and scalable and a whole bunch of different things. But thank you.
Any questions for Nosh? So it's more like feedback rather than a question. I mean, it's kind of very exciting tool. It's definitely useful for like data exploration. It's kind of answer Kumar's question. Like, it's kind of, if we can export our data to this kind of Google spreadsheet, it's give us like tremendous capability of different charting or analysis, and in an interface that people are more familiar. Not only a developer can utilize this data. It's fantastic work.
Yeah, and part of the reason for me building this was to actually understand like what these sensors were spitting out, because I could see the data on the app, but often those interfaces are not great, and you actually want to see, what does this mean if I average it out, or what does it mean if I look at it over a longer time period? And because this data is locked up in these proprietary stores by each of the vendors, it's really hard to deal with. But with OpenMHealth, it was easy to sort of build this app. And I do want to mention for those who are actually very familiar with the OpenMHealth software, so this uses the OpenMHealth shim server, but it should be pretty easy to get this to work against any DSU. So if there's any app that's out there that's using the OpenMHealth DSU, it's probably pretty easy with minimal work. This can be actually hooked up to
Ability your pan. Any of those. So will you use Granola?
Well, so part of the idea behind this was not to actually have to build anything on the phone. One of the big challenges, though, is that if you don't have a sensor for step counts, for example, you need to download some app from someone like Jawbone or something, so it actually collects that data and pushes it into their systems. But with Hipbone, probably the answer would be that I would just install Hipbone and then perhaps add something to the shim so it can pull that data from Dropbox, so, or wherever that data ends up. Yeah.
Well, does anyone have any other questions? Or so this is just a little taste of some of the stuff people are working on locally in New York City. So thank you all for coming, and if please come to the summit next month. There's going to be more of these types of show and tells and people showing what they've worked on and talking deeper about how to expand the platform so it could be fit in more uses. Thank you so much, everyone, for coming, and have some more, if there's any more beer or wine, but please have some.